Hello my dear students, welcome to my physics class. Our today's topics are flow of fluids and viscosity. Let's start now. Flow of fluids. At first we have to know what is fluid. The materials which flow are called fluid. Liquid and gaseous substances are combinedly called fluid. Streamline flow. There are two types of flow, streamline flow and turbulent flow. Here first one is streamline flow. During flow of fluid, if all particles follow the path of the advanced particles moving to the front with same velocity, then that flow is called streamline flow. Here consider a liquid is flowing through the path A, B, C, and consider any particle of this liquid is crossing the point A with velocity v1 and crossing the point B with velocity v2 and crossing the point C with velocity v3. Then if any new particle cross the point A, it will cross the point A with velocity v1 and it will cross the point B with velocity v2 and it will cross the point C with velocity v3. That is, all the particles cross the point A with velocity v1, cross the point B with velocity v2 and cross the point C with velocity v3. This is streamline flow. Now turbulent flow. The flow of fluid in which the fluid undergoes irregular fluctuations or mixing, in contrast to streamline flow in which the fluid moves in smooth paths or layers. That is, in turbulent flow the motion is not same as streamline flow. In turbulent flow, the speed of the fluid at a point is continuously undergoing changes in both magnitude and direction. But in case of streamline flow, at a certain point, the velocity of all the particles are same. Here turbulent flow. Here the particles of the fluid are moving in zigzag path, therefore it is turbulent flow. And here streamline flow and turbulent flow. First one is streamline flow and second one is turbulent flow. Now viscosity. The property of the fluid by virtue of which it opposes the relative motion between its different layers is called viscosity. Here, when fluid flows, then how much a fluid is resistive is measured by the viscosity. That is, the more the resistive a fluid, more its viscosity. As an example, the flow of honey is more resistive than the water, therefore the viscosity of honey is more than the viscosity of water. Here low viscosity and here high viscosity. If a fluid flows on a horizontal surface, then its motion is divided in different layers. The layer of the fluid which is adjacent to the surface is stationary and other layers are in motion. That is, by the viscosity of the fluid we can know how much resistive a fluid is. Here, velocity gradient. Consider a liquid or fluid is moving in layers. Here two layers parallel to each other, and area of these two layers are same. Consider the velocity of the fluid at this layer is v, and at this layer is v plus dv. That is, change in velocity is dv, and distance between these two layers is dy. Area of these layers are a, velocity at this layer is v, and velocity at this layer is v plus dv, and distance between these two layers is dy. The derivative of velocity with respect to distance is called velocity gradient. That is, velocity gradient is equal to d dy v. Now, Newton's law of viscosity. If there is a relative velocity between two layers of a fluid, then the tangential viscous force which acts opposite to the flow is directly proportional to the surface area A and the velocity gradient d dy v of the layers at constant temperature. That is, from Newton's law of viscosity, we can measure the magnitude of the viscous force which acts opposite to the motion of the fluid. Thus, viscous force F is proportional to surface area A when velocity gradient is constant, and viscous force F is proportional to velocity gradient d dy v when surface area A is constant. Or F is proportional to A d dy v when all quantities are changed. Or F is equal to eta A d dy v. Here eta is proportionality constant. Here for this proportional sign, here proportional sign is omitted, and here constant eta is included, and this constant eta is called the coefficient of viscosity. And coefficient of viscosity eta depends on the nature of the fluid and the temperature. Coefficient of viscosity. Here viscous force F is equal to eta A d dy v. From this equation, if A is equal to 1 unit and velocity gradient is equal to 1 unit, then viscous force F is equal to eta into 1 into 1. That means viscous force F is equal to eta when A is equal to 1 and velocity gradient is equal to 1. Therefore, from this we can define the coefficient of viscosity. Now, the definition of coefficient of viscosity: the tangential force required to maintain unit velocity gradient between two layers of a fluid of unit area at constant temperature is called coefficient of viscosity of the fluid.